Our group decided to work on the Billionaire statistics dataset, which is a dataset based on the world's top billionaires, and it covers their wealth distribution, demographic trends, economic indicators, and geographical data. It also contains variables spanning net worth, world ranking, gender, age, industry, and citizenship. And what we were interested in was that in today's social and political climate, it is important now more than ever to recognize the power and influence of billionaires. Billionaires are highly influential individuals who can sway government officials and inform policy decisions. This is what interests us in the topic and motivates us to study the factors that make a billionaire. So our group decided to split our research into 4 subcategories, the first being geographical characteristics, economical characteristics, industry trends, and social and educational characteristics. My research topic focused on geographical characteristics that affect billionaire wealth, and this visualization specifically tries to answer how billionaire sources of wealth, if they're either self-made or not self-made, vary across different industries and regions. So on the left side of the visualization, we can see a stacked normalized bar chart, which is aggregated by continent. And we can also hover over it to see a tooltip of the actual counts of billionaires within this continent. And also linked to this is a filter for the industry. So let's say we wanted to filter by service. We can see that there are billionaires in Asia, Europe, and North America. And if we wanted to compare it with a different industry, we can say manufacturing. You can see that along with Asia, Europe, and North America, there's also Africa, Oceania, and South America. So next, let's look at the chloropleth. So on the right of the bar chart, there's a chloropleth, which shows the average net worth of the billionaires within the country. And we can hover over that to see the exact average amount. And also on the chloropleth, we have a superimposed pie chart, which shows the proportion of self-made to not self-made within the country. So in Canada, we have 71% of billionaires are self-made. And if we hover over the blue part, we can see that about 29% of Canadian billionaires are not self-made. So next, let's move on to the search feature. So if we wanted to see an unaggregated view of the country, we can search the country here. So let's say we wanted to search the specifics of Canadian billionaires within manufacturing. We can say Canada, and it will update the bar chart and show that 100% are not self-made. And if we hover over it, we can see the exact count of 2 Canadian non-self-made billionaires.
Hello, I'm Chloe, and today I will be talking about the economic characteristics that contribute to the success of a billionaire. And the question that I seek to answer with my visualization that I will be presenting is, are there correlations between billionaire wealth and economic indicators such as GDP in their respective countries? And to answer this question, I constructed a box plot with the country of billionaires' residences, GDP, on the y-axis and the billionaire wealth group to which they belong on the x-axis. And essentially, by using a box plot, I seek to answer this question by comparing the median GDPs across billionaire wealth groups. As we can see here, because the distribution of GDP is so overlapping for each billionaire wealth group and the medians appear to be roughly equal, it is hard to say with very strong levels of confidence that there is any indication that GDP in a billionaire's country of residence contributes to their success as a billionaire. To illustrate this further, I have a tooltip on each distribution, which highlights the quantiles, the max and the min, and the billionaire wealth group to which this distribution belongs. And I've also highlighted the distribution of wealth in billionaires just to show how skewed this data set really is, where we have only extremely wealthy billionaires in this top group here, with the vast majority of billionaires falling below the 35 billion plus range. And to illustrate that further, I have made a bidirectional plot where we can shift click and take a look at the different distributions, faceted, I guess, by the bin to which they belong. And as I said, this is bidirectional, so we can click in the opposite direction and see the box plots for these different levels of billionaire wealth. I also decided to investigate if perhaps industry is another contributor to billionaire success. And to answer that question, I have constructed a drop down with the different industries present in our data set. And as you can see, just as we're clicking through the different categories here, the billionaire wealth distribution tends to be unwavering across industry. We have this high left peak here and then this right tail off to the side. And this trend tends to be consistent throughout most industries. And therefore, I would say we don't have any conclusive evidence that the industry within which a billionaire operates contributes to their success. And yeah, these two findings from this visualization provide sort of an insight into what makes a billionaire.
Hi, so I'm Maxine and I'm doing industry trends. So as you can see, the research question that this view attempts to answer is which industries have the highest number of billionaires and how do their net worths compare? So with that being said, in terms of my view, I really thought that again, like this, we could just plot in terms of a bar chart. So we can see that there's the different industries right here, and then we can see the count of billionaires that originate from this industry. And then if we look to the right side of the view, we can see all of the industries, their distribution of the average net worths of their billionaires, are plotted here. And it is a lot in terms of seeing this for the first time. Like, I understand that it could probably overwhelm someone's cognitive load. So, with that being said, you can also select different industries that you might be interested in, and they'll update accordingly. And this is a bidirectional plot. So, for example, if I was curious about maybe this one because it seems to have the most billionaires here. I could click on it and then it would update here. But again, even with those functions, like I still thought that it'd still be pretty overwhelming. So I I inputted a drop-down menu here that's an alphabetized list of countries, so you could really reduce the number of information and data that you're looking at. So, for example, if we were to look at Germany, we can see that it reduces the number of industries that are shown to only the ones that are shown in Germany. And then again, it updates both the histogram and the bar chart accordingly, and this function uh, persists even when we filter for a specific country. And then one other thing that I thought was um, really nice was for comparison and seeing which industries have the most number of billionaires is ordering this in descending order, as users can make very easy comparisons between industries and inform their decisions that way.
Is Olivia. I will be presenting on the social and educational characteristics of our dataset of what makes a billionaire. So yeah, if we scroll down, the question I will be talking about today is how does the likelihood of being a self-made billionaire vary based on the level of tertiary education enrollment in their country? And as you can see from my charts, I built out a pie chart of self-made to not self-made billionaires, as well as a choropleth showing all the countries. And so for the choropleth, I have a tooltip. It lists the country name and the enrollment percentage for each. And as you can see, there's a bidirectional interaction with the pie chart that shows the country given. As we can see, this is the false. It gives billionaire count and it gives country name. And it shows the true and the false proportions. And yeah, you're also able to use shift click, which goes like this if we really want, and this will affect the pie chart as well. If we double click out, it goes back and you can see the total proportion again of our self-made to not self-made billionaires globally. Another cool tip is that we can change the color if we really want of our pie chart from not self-made to self-made if we really like. That's one widget. And then my next interaction that I made is through these button widgets. When you click them, it shows the top 5 gross tertiary education enrollment percentages. So these are the top 5 highest, with Greece being the number 1 with an enrollment percentage of being 136%. And then we can go back to the world view here. And something that we noticed from our findings is that although from our global proportion chart, we see that most billionaires are actually self-made. However, when we look at our top 5 tertiary enrollment countries, we notice that actually most of them are not self-made, which I found really interesting. This suggests that a high rate of gross tertiary education enrollment does not necessarily imply that a billionaire will use their education to amass wealth independently, which I found really interesting.